Yeah, I clean this up for next year. But when a kid jumps in the water, so a kid, when Cliff jumping into the water, put like maybe a comma here, he ran. He had a running start of 4 meters. Go back. So you guys should pay attention in English class. Goodness gracious. He had a running start of 4 meters per second. The height of the cliff was unknown, but the range from the cliff where he hit the water was 12 meters from the base. 12 meters from the base. Fill in the chart and answer the questions. Oh gosh, I feel like I got enough. I don't know. There's my 0. Negative 9.8 meters per second squared. Golly, doesn't feel like I got anything. Well, that one I know too, because it's right as soon as you use the cliff. So he's got this thing going on. Let's just go. This kid, he's jumping, running fast. I don't know what that. Oh, look now, he looks like he's falling. Whatever. It's running over the cliff. And there's some water down here. It's going. And this down here below is 12 meters. That's the range. 12 meters. 12 meters. That's the water. So I want to let you know, I have not done that. My kids do this. It's not really doing 10 meters, but all right. Now he's got to run, and he's going at 4 meters per second. 4 meters per second. And that actually stays constant. Remember, that should be like parallel. 4 meters per second. 4 meters per second. Doesn't really look like 4 meters per second. 4 meters per second. Yeah, like 4 meters per second. That arrow is always 4 meters per second. 4 meters per second. 4 meters per second. 4 meters per second. Oh, well, remember, like, usually we don't start in the x-axis, but this time you have to because we don't have time. We don't have 3 things over here. So find time here in the x-axis. Wow. Whew. So, spicing things up. You can handle it. Hey, well, what equation am I going to use? Let's see. I'm going to find time. A is 0 so that's 0, that's 0, that's 0. The only one that's really interesting is that middle one right there. And this part's 0, so I'm just going to write D equals VT. D equals VT in the x-axis, that's what we're studying. D is 12 meters. No, I'm not going to write the units. Sorry. Well, whatever. And I just want to confuse you guys. I'll erase it. Goodness gracious. 12. That's 12 meters. Your velocity is 4 meters per second times t. Divide by 4, divide by 4. 3 seconds is your t. 3 seconds. Oh, wow, that was pretty fast, Mrs. Nagel. And then I put my 3 seconds over here. Oh, now I have my 3 things. I wonder if I could solve for dy. Yeah, maybe. Let's see. Let's do y. To knock down onto the y-axis. The y-axis. Y-axis. What am I looking for? You want to try that one? dy? Do y-axis? All right, do that one. Oh, wait, you can't see me. And I have time, so I can use them. I'm trying to find D. That looks painful. Just use this one. Here. D equals V initial t plus 1/2 AT squared. Because of this, that term goes to 0. So D in the y-axis is 1/2 times negative 9.8 times my t, which is 3, and I'm squaring it. Put that into a calculator. How you do that? Make sure you guys can do this. I don't know. Some people are getting it wrong. I hate that. I can't see. I'll put them over here, I guess. Can you see it? I don't know. There we go. Maybe 0.5. Don't even have it on. Clear it. 0.5 times 9.8. I know it's going to be negative because it's going down, but whatever. 9.8 times 3, and then I hit the squared button. It's right there. Equals. That really feels familiar. Ah! Oh, well, whatever. That. All right, meters, and then I'm going down. Downwards. So remember, if you're going down, it's the or influence going down. Negative. So negative 44.1 meters going down. That's like really high. It's like jumping. I'd be scared to jump. That probably hurts when you hit the water. A little belly flopping going on. All right, V final. Let's go. V final. Easiest V final one is like this one. Top one. Yeah. Initial 0. V final equals 9.8, or negative because you're going down, times time, 3 seconds. It's almost 30. Let's put that in. 9.8 times 3. Yep, 29.4. V final equals 29.4. It's going down. The unit is meters per second. 29.4 meters per second. Wow, Mrs. Nara, that was pretty good. I'm getting good at this stuff. You guys are amazing. Woohoo! You're doing X and Y combinations. All right, now we gotta bring it all in. Bring it all in. I gotta do the other part. So now you have 4 going this way, right? 4 meters per second going this way, and then you get this one. 29. All right, yeah, technically it's negative, right? 29.4. And I gotta find this arrow. Gotta find the resultant. That's weird, because that's what I'm trying to find. That's the blue. That's the one. Find that. So how do I do that? How do I even know how to draw it? I take that arrow and I match it over here. Then I gotta find that impact angle. So I'm just gonna redraw it down here. So I have this. 4 meters. I'm just gonna write 4 per second. This is like 29.4 per second. I'm trying to find that length. Find that. That's a squared plus b squared equals c squared. So c squared equals 4 squared plus 29.4 squared. La, 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 da, da, da. C equals 4 squared plus 29.4 squared. 88036. There's a square there. Square root both sides. Hello? 2. Second answer key. 29.6. What? Dang it. Is it really true? Did I do something wrong? Maybe I round up 29.7, I guess. Wow, is that really true? Yeah, I guess so. Really going anything this way, and it's going really fast down. So this, like, out of proportion, I mean, it's really like 4 meters per second, and then like 29. I mean, that angle is going to be like almost close to 90. And like, there's your impact. I mean, like, that's what it really should look like, I guess. I'm trying to find that impact angle. It's like almost, I don't know, let's go check. All right, put the units here. Meter per second. What's that? What's the green arrow? 29.7. Gosh, I hope I didn't make my mistake. I'll figure out my, well, that's what that is. 29.7. All right, that's my angle. Tan theta is opposite. 29.4 divided by adjacent, which is 4. Theta equals inverse tan 29.4 divided by 4. Oof. Oh, I got that in the answer. So I'm going to go second inverse. No, I'm not going to put anything else in. Hold on. I'm going to put it in. 29.4 divided by 4. Theta is, yeah, it's almost 90. 82. Ooh, see that. For last drop top mass, I'm probably around there, 2 degrees. There you go. Wow. Done.